So these are the targets 8 through 9 notes. We're going to be working with matrices today. Target 8, we're doing addition, subtraction, and then solving, and then target 9, we're multiplying. So starting with target 8, let's actually begin by talking about what a matrix is. So a matrix is defined as an array of numbers. The size of a matrix is defined by the number of rows and columns that it contains. A matrix with m rows and n columns is called an m by n matrix, or m by n matrix, while m and n are called its dimensions. So basically we can say that a matrix is however many rows by however many columns. So you could say it's like 2 by 3, or 1 by 3, or 3 by 1, or something like that. Every little array of numbers you see here, that's a matrix, that's a matrix, this is a matrix, this is a matrix. Those are all matrices. Okay, they're just arrays of numbers. And let's talk about rows and columns. So rows, those run left to right. And then columns, those run up and down. So if we look in this first problem that we're given, A, that first matrix, however many rows by however many columns it has would be the dimensions. Let's see. The rows running left to right, well, we have this row and we have this row. So we have 2 rows, so we can say 2 by, we make a little x, and then columns up and down. It has 1 column. This is a 2 by 1 matrix. And then the other one, same thing. We have 2 rows, so we say this is 2 by however many columns it has, which is 1. This is also a 2 by 1 matrix. So if we read the little sentence, that little blurb right above A, it says to add or subtract 2 or more matrices, they must have the same dimensions. If they don't have the same dimensions, we say the solution is undefined. So if we cannot add or subtract, the problem is just undefined and we can't even do it. So in A, we can actually see that this is 2 by 1, this is 2 by 1, same dimensions, so we can go ahead and add or subtract. So we're adding, and basically all I want to do when I'm adding or subtracting matrices is I want to take every single term in the positions and add them or subtract them together. In this case, we're adding. So basically, in the first matrix, that -3, it's on the very top. It's in that position. I look at the matrix on the right, and that +3 is in the top, same position on the right side. So I'm just going to add those numbers together. -3 plus 3 gives me 0. And then my next one, 2 plus a -3, or 2 minus 3, gives me -1. Here's my answer. Now let me explain this just a little bit. So when we add or subtract matrices, if we can add them or subtract them, which means they have the same dimensions. So if we can go about doing that, our answer is just going to be a matrix of the same dimensions. So if I'm adding 2 matrices that are 2 by 1, my result is going to be a 2 by 1 matrix, just like we see here. So we're not going to get just like one number answer. When we add and subtract matrices, we're going to get another matrix as our answer. Okay, let's look at B. Here I have 2 rows and then 2 columns. This is 2 by 2. And then here I have 2 rows and 2 columns. This is also 2 by 2. Same dimensions. I can go ahead and add these together. In this case, I'm actually subtracting. My answer is going to be a 2 by 2 matrix, just like what we're adding and subtracting, or subtracting together, sorry. Okay, so I'm going to go ahead and highlight again what I'm going to be subtracting in different colors. So, as you can see, that -6 and that -2 are in the same position. I'm just subtracting those. -6 minus the -2 gives me -4. Then I'm moving on to the yellows. 4 minus 3 gives me 1. 5 minus 6 gives me -1. And then 6 minus 1 gives me 5. Here is my answer. Alright, let's move down to C. Alright, I have 2 rows and 2 columns, so this is a 2 by 2 matrix. And this one I have 3 rows and 1 column, 3 by 1. Those are not the same dimension. So in this case, my answer is undefined. I can't even do that. Let's look at D. I have 1, 2, 3, 4 rows and 2 columns. This is a 4 by 2 matrix. And then the one on the right, I have also 4 rows and I also have 2 columns. Same dimensions here. So I can go ahead and perform my addition or subtraction. In this case, we're subtracting again. So I'm going to go ahead and subtract every term. I'm going to go ahead and highlight like I've been doing. I'm going to run out of colors here. There we go. All right. Every color I'm adding or subtracting together. So my resulting matrix is going to be another 4 by 2. I'm going to add those top left green, or subtract. -5 minus a -2. So -5 plus 2, so -3. I'm moving down. I'm going to move down to the blue. -4 minus a -4 gives me 0. 5 minus a -4 gives me 9. And then -5 minus a -4 gives me -1. Then I'm going back up to the top right. 4 minus 2, that's 2. 5 minus 5, that's 0. -3 minus 4 is -7. And then 1 minus 4 is -3. And there we go. That's my answer. Alright, it says we can also combine the operations or add and subtract with more than 2 matrices. So I can technically go ahead and add 3 matrices all together. Now I'm not going to take the time to highlight every term in this one like I have before, but I'm just going to make a dot with my blue pen next to every single one that I'm working with here. Alright, so if I have a 1, 2, 3, 4 by 2 matrix here, and I have a 1, 2, 3, 4 by 2 matrix here, and I also have a 1, 2, 3, 4 by 2 matrix here, I can add all those together. So you have to check that before you do anything. Alright, now that I know that I can do these operations, my result is going to be another 4 by 2 matrix. And right now I'm going to work with -6, +2, and -5. So I'm just going to add straight across there because I have addition symbols. I have 2 plus signs. So I'm doing -6 plus 2 plus -5. All right, -6 plus 2 gives me -4. -4 plus -5 gives me -9. All right, now moving on to the next one. 5, -5, and -4. 5 plus a -5 gives me 0. 0 minus 4 gives me -4. Moving down, -5, 3, and -4. -5 plus 3 is -2. -2 plus a -4 is -6. 3, 4, and -5. 3 plus 4 gives me 7, and 7 plus a -5 gives me +2. Alright, back up to the top right. -6, -3, and -5. -6 plus a -3 is -9, and -9 and a -5 gives me -14. Moving down, -3, 0, and -1. -3 and 0 gives me -3, and then -3 and -1 gives me -4. 4, 4, and -3. So 4 plus 4 is 8. 8 plus a -3 is 5. 0, -5, and -3. 0 minus 5 is -5. -5 plus a -3 is a -8. There is my answer. So you don't have to take the time to highlight every term that you're adding or subtracting, but it does kind of help. Now, just note that it takes a little bit more time, but whatever is going to get you the right answer, do whatever you feel more comfortable with. All right, so B. I'm adding all 3 of those matrices together. Let's see if they all have the same dimensions here. So the first one, I only have 1 row here, but I have 3 columns. So this is a 1 by 3 matrix. This one, 1 row and 3 columns. Also a 1 by 3. This one is a 1 by 3 as well. So I can, in fact, add all these together. I have addition in both cases. Now, those could be any operation. Those could be subtract and add and subtract, add, both subtract. But when we're doing addition and subtraction, we have to make sure that they all have the same dimensions in order to do those operations. So my result is going to be a 1 by 3 matrix. So I'm going to erase all this. It's in my way. And let's do this math. So negative 2 plus negative 2 plus 4. Negative 2 plus a negative 2 gives me negative 4, and then negative 4 plus 4 gives me 0. Negative 1, negative 3, and negative 4. Negative 1 plus a negative 3 gives me negative 4, and then negative 4 plus a negative 4 gives me a negative 8. 5, negative 6, and 2. 5 plus a negative 6, or 5 minus 6, gives me negative 1. Negative 1 plus 2 gives me 1. And there's my answer. And then the very last section of this target 8, it says we can have an undefined matrix that we need to solve for using 2 other given matrices. So basically we're going to use our solving skills here. So we're just using our solving skills. Let's look at A. So it says Z plus that matrix equals another matrix. Alright, so in order to solve for Z, I want to get Z all by itself. Using my solving skills, I know that to undo that addition right there, I'm going to have to subtract. So I'm going to subtract that entire matrix over to the right side, just like I would do in a normal solving problem. They look kind of cramped there, but it's okay. So this matrix minus that one is just 0, and I get Z equals some new matrix. Well, let's look at this. On the right, I have this matrix minus this matrix. Well, I have to ask myself, can I even do that subtraction? Let's see. The first matrix is 1 row by 4 columns. So that's a 1 by 4 matrix. The second one is a 1 row by 4 column also. It's also a 1 by 4 matrix. So yes, I can do that subtraction there. I was just checking. Okay. So my result is going to be a new 1 by 4 matrix. So I'm going to take 5 and subtract negative 4, which means I'm just adding 4. So 5 plus 4 gives me 9. And then 6 minus a negative 5, or 6 plus 5 gives me 11. Negative 12 minus a negative 5, or negative 12 plus 5 gives me negative 7. And then 8 minus 8 gives me 0. And there's my answer. Alright, let's do B. Okay, so I have 2 times y equals this matrix. So in order to get y by itself, I'm just going to use my normal solving skills here. In order to undo multiplication, I'm just going to divide by 2. Dividing both sides by 2. So on the left side, I get y equals something. Now, when I take a matrix and I divide it by a number, some constant number, 2 or 3 or 4, I'm taking every term in the matrix and dividing it by 2. I'm doing every term, and I'm doing that division to every term. So my resulting matrix is going to be the exact same size as my original one. So it's going to be a 2 by 2. And I'm taking each term and dividing it by 2. So negative 6 divided by 2 gives me negative 3. Negative 8 divided by negative 2 gives me negative 4. Negative 10 divided by 2 is negative 5. And then 18 divided by 2 is 9. So there is my answer. Okay, so moving on, this is actually target 9 notes. We just did target 8 on the first page. This is target 9. Okay, so it says we can multiply 2 matrices A and B if the number of columns in matrix A is equal to the number of rows in matrix B. Otherwise, the product is undefined. So they're asking us in the first problem, can we multiply these? And if so, give the dimensions. Well, let's look at what we have here. Let's look at this picture right here. If A is a matrix, an array of numbers like we've been seeing, and its dimensions are m by n, and then we're trying to multiply it by this matrix B, and its dimensions are n by p, just coming up with random numbers here, random letters. if these two numbers are the same, then we can multiply those two matrices. We get a green check. Yes, we can multiply those. The result, or the dimensions of our matrix in our answer, is going to be this by this. So our answer is going to be a matrix of M by P dimensions. That's our result. So let's actually look at one of these. Let's try it. So they're just asking us if we can multiply these. They're not asking us to actually multiply. So can we? Well, let's look. Let's look at the dimensions of the first matrix. We have 2 rows by 2 columns. This is a 2 by 2 matrix. In B, I have 2 rows by 1 column, 2 by 1. So those are different dimensions. Now we wouldn't be able to add those or subtract those, but we're trying to see if we can multiply. So we're looking for different criteria here. We're seeing, is this number and this number the same? Yes, 2 is the same number as 2. We can multiply. Our answer is going to be a matrix that is 2 by 1. Our matrix is going to be so our answer will be a 2 by 1 matrix. We found that out by listing the dimensions of each one. So it's going to be a matrix of this size. All right, let's do the next one. A is 2 by 2, and B is 1 by 2. All right, let's see. Is this number and this number the same? Basically, those inside numbers. The inside numbers over here, the inside numbers over here. Is 2 and 1 the same number? No, those are not the same number. We can't even do this multiplication. So in this case, this would be undefined. So it says, otherwise the product is undefined, meaning if we can't multiply, we just write undefined as our answer. All right, it says multiply the elements of each row in the first matrix by the elements of each column in the second matrix, then add the products. Okay, that's a lot of words. Basically, that is telling us how to multiply matrices, because it's a little bit different. You can't just multiply like A times E, and then B times F, and then C times G, and then D times H. It doesn't work like that. That's only for addition and subtraction. So multiplying matrices actually takes a little bit more work. Okay, so use the following matrices. A equals this matrix, and B equals this matrix. Well, on A, if we start with A, which I crossed it out, they want us to evaluate 3 times matrix B. Well, if we're just multiplying a matrix or dividing a matrix by a single number or a constant, all we're doing is taking each term in that matrix and multiplying or dividing by that single number. So we're taking B and multiplying it by 3 here. Our result is going to be a matrix of the same size of B. So B is a 2 by 2, which means our answer is going to be a 2 by 2. So let's go ahead and do that. 3 times 1 gives me 3. 3 times 3 gives me 9. 3 times negative 4 is negative 12. And 3 times negative 2 is negative 6. That's my answer for A. Now B. This is where it gets a little difficult. So go slow, hang in there, and we'll do this one very, very meticulously. So it says evaluate A times B. I'm going to rewrite both those matrices. So I'm multiplying this matrix A, which is 2, 1, negative 3, and 5, times 1, 3, negative 4, and negative 2. Let's see if we can even multiply these matrices. This one on the left is a 2 by 2, and the one on the right is a 2 by 2. Are the numbers in the middle the same? Is 2 the same number as 2? Yes, it is. Our result is going to be a matrix that is the size of 2 by 2. Our result is a 2 by 2 matrix. All right, well, now that we figured that out, I'm going to erase it. And let's do that math. In order to multiply matrices, I'm first going to take, in my left matrix, I'm only focused on the rows. So I'm only looking at this, and this. And in my second matrix, I'm only looking at the columns. So this and this. All right. Now, when we multiply, we're going to take each row in the first matrix and multiply it by each row in the second matrix. Now, I'm going to kind of go back here and delete what I just did. And right now, my very first operation here is going to be focusing on the first row in the left one and the first column in the right one. Don't forget, my answer is going to be a 2 by 2 matrix. We already figured that out. Let's see, equals. Let's start. What I'm going to do is take 2 times 1 and then -3 times 3 and add those together. So 2 times 1 gives me 2. And then -3 times -3 times +3 gives me -9. So when I add 2 and -9, I'm essentially subtracting 2 minus 9. And that's what goes in my top left spot there. Because if we were to like shift this right matrix over to the left, where would that row and that column overlap? Well, it would be that top left spot. All right, let's go ahead and move on to the next one. So I'm going to kind of go back up here and erase a little bit. I'm still working with the first row in my left matrix, but I'm going to move on to the second column in my right matrix. This time I'm taking 2 times -4, and I'm taking -3 times -2 and adding those together. So 2 times -4, multiplying whatever's in the red together. So 2 times -4 gives me -8. And then -3 times -2 gives me +6. So I'm going to add 6. And that's what goes in my top right position. Okay, now let's move on. Just rewriting here because I was using my marker. Okay, moving on to a new row. So I'm going to work with my second row in my first matrix now, and I'm going to work with my first column in my second matrix. Now I'm multiplying 1 and 1, then I'm multiplying 5 times 3 and adding those together. So 1 times 1 gives me 1, and then 5 times 3 gives me 15, so I'm just doing 1 plus 15. Okay. My very last position, I'm going to stick with that second row in my first matrix, but I'm moving on to the second column in my second matrix. Moving on to this one right here. The only pair we haven't multiplied yet. 1 times -4, I'm adding that to 5 times -2. So 1 times -4 gives me -4. And then 5 times -2 gives me -10, so I'm essentially subtracting 10 here. And that's my answer. But not exactly. I have to actually do that math in green. So my real answer, my final answer, is a matrix that looks like this. 2 minus 9 gives me -7. Moving down, 1 plus 15 gives me 16. And you can go down or left and right, whatever. -8 plus 6 gives me -2. And then -4 minus 10 gives me -14. All right, that is my final answer right there, that 2 by 2 matrix. So a lot of work went into that for just a tiny little matrix of 2 by 2. But multiplying matrices is that time consuming. It's that meticulous. Let's do a couple more. So last page in the notes, it says use the following matrices A and B to evaluate, and then evaluate both those matrices. Multiply together. So in A, it just wants me to take matrix B and multiply it by -2. So I'm going to take -2 times matrix B Basically, I'm taking every term in that matrix and multiplying it by -2. So my answer is going to be a matrix of the same size, 2 by 2. So -2 times -1 gives me +2. -2 times 2 gives me -4. Whoops. -4. -2 times 3 gives me -6. And then -2 times 0 gives me 0. Anything times 0 gives me 0. And that's my answer. Here's where we get into the meticulous part. I'm multiplying both matrices together. Now let's actually check really quick. Can we even multiply those matrices? Remember what we have to do here. We have to take the dimensions of both, see if those two inside numbers are the same, and then I'm going to say what my new matrix or my answer matrix is going to be, what the dimensions will be. So this is a 3 by 2. 3 rows and 2 columns. This one is a 2 by 2. So I'm going to check. Is 2 the same number as 2? Yes, it is. My result is going to be a 3 by 2 matrix. Result, 3 by 2. All right, now that I have that all figured out, I know my result is going to be a 3 by 2 matrix, which is going to look something like this. Taller than it is wide. All right, I'm going to erase everything that I just did, because I need to see those numbers. So it's going to be a 3 by 2 matrix. So I'm first going to take the first row in my first matrix and the first column in my second matrix and do that. Let's see. 3 times -1 and add that to 0 times 2 and see what I get. Well, 3 times -1 gives me -3. And then 0 times anything is just going to give me 0. So I can just say the plus 0. You could leave that as -3 if you want, but I want to also make sure that I know that I'm doing addition there. All right. Sticking with that first row in my first matrix, I'm going to move on to the second column in my second matrix. So 3 and 0 here. So now I'm taking 3 times 3 and 0 times 0, and adding those together. So 3 times 3 gives me 9. 0 times 0 gives me 0. 9 plus 0. All right. Then I'm moving on to a totally new row. Second row. All right. First column first. 1 times -1. -2 times 2. And add those together. -1 times -1 gives me -1. -2 times 2 gives me -4. So I'm adding a -4, which means I'm just subtracting 4. All right, sticking with that second row, moving on to my second column. 1 times 3, and I'm adding that to -2 times 0. So 1 times 3 gives me 3. -2 times 0 gives me 0. All right, and then finally, I have to do my third row in my first matrix, which is this one. I'm first going to multiply it by this column. So 0 times -1, and I'm adding that to 4 times 2. So 0 times -1 is just 0, and then 4 times 2 is 8. So 0 plus 8. My final operation here, taking the last row and my last column and multiplying them together. So 0 times 3, and I'm adding that to 4 times 0. Well, 0 times 3 is just 0, and then 4 times 0 is just 0, so I literally just have 0 times 0, or 0 plus 0 here. All right, let's see what this result is going to be. Let's actually do this math. -3 plus 0 is -3. -1 minus 4 is -5. 0 plus 8 is 0. 9 plus 0 is 9. 3 plus 0 is 3. And 0 plus 0 is 0. And that is my answer. And that concludes the notes. So I would write down maybe a summary of targets 8 and 9. How do you know when you can add or subtract matrices? how do you know when you can multiply matrices? I would maybe write those steps in there so you remember how exactly to go about doing that and what your criteria has to be. Maybe also something to write down would be like, how do you know a row that is different from a column? What do rows look like? What do columns look like? Rows run right to left or left to right, and then columns are the up and down ones.